piecewise functions. What's today? The 25th. All right, so let's start with just basically what the definition is. Okay? What would you expect something that involves the word piecewise would be? What were you saying, Liz? What do you think, Maya? Yeah, separated, it's, so it's a function made up of several different pieces. Okay, that's exactly what it is. So if we look at the graph here, I have 2 lines. That means I have 2 pieces to it. Okay, does that make sense? So to look at or evaluate what some of the points are, you just look at, let's see, where are we at -3? Well, 1, 2, 3 gives me a 1, 2, 3, 4. This point right here. And so I have a 5 because my ordered pair is -3, 5. Does that make sense? So when you're evaluating it, you only use the piece that corresponds with that X value. Yes? Corey, where'd I lose you? That's a great face, by the way. Yeah, so I went, because this is my X, and I went to where it hit on the graph. Perfect. All right, so f of 7 is like looking at my X value for 7. So I look at my graph, and 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. That's this point here, and so the f of 7 is 6. No, it honestly really doesn't. No, it honestly really doesn't. The hardest part is tomorrow when we graph them. You take the equation and you graph it. Like down here, we're going to take that equation, we're going to graph it. That's it. Not hard. That's why it's a little mini unit, because it's quick and easy. All right, so the f of 3. I have 1, 2, 3. Now look, I have 2 different points that hit when x is equal to 3. Okay, which one do I use? Why do I use the closed? Because that's the actual point. Remember, if it's an open circle, does not include the point. So that means I have to use 1, 2, 4. And so I use the right segment because it had a closed circle. So the point is included. Good? Easy peasy? All right, let's look at the next graph then. Okay, so if f is -4, what's my point going to be? I'm going to be at that point here, so it's going to be -2. Perfect. What about negative 3? It also is going to be negative 2. I have this one up here, but it's the open dot, so I want the point down below at negative 2. Easy. Okay, negative 1. 5, perfect. And what about 0? What'd you say, Austin? Yeah, it's nothing. So it's like saying the null set, okay? Because at 0, those are both not included, so you don't have an answer. It does not exist, okay? You can put does not exist, null set, any of those are fine. Awesome. What about 5? 1, 2, 3, 4, 5. I agree with 5. Perfect. And then what about negative 2? Would be 6. Perfect. All right, feeling good about those. Easy peasy. Awesome, awesome. Okay. Now, what happens if I don't have an actual graph? I just have 2 equations. What do you think? Just plug it into the equation. The hardest part of this entire unit is this section right here, and which equation do you pick? Okay? So, for instance, look at my first equation. 2x plus 10. We use equation 1 when x is less than or equal to 0. And I use equation 2 if x is greater than 0. So you have to look at your number to decide which equation you're going to pick. So if f is negative 10, is that less than or equal to 0? Or is that greater than 0? Less than. So negative 10 is less than 0, so I'm going to use equation number 1. And so I say, hey, the f of 10, negative 10, is going to be negative 2 times negative 10 plus 10. Good? Let's simplify. So negative 2 times negative 10 gives me 20 plus 10, and so I get 30. That's the hardest part of this whole unit. Can we do that? Yeah. All right. What about f of 1? Which one am I going to use? Equation 1 or equation 2? 2, because 1 is greater than 0. So the f of 1 is going to be 1/2 times 1 plus 4. So I get 1/2 plus 4. So I can just say 4.5, or I can say 4.5, whichever you want to do is fine.
So it wouldn't be wrong if we put 1.5?
No, not at all. I would prefer a decimal, but I'll take it either way. I'm okay on that. All right, last one, f of 0. Why the first one?
Because it says x is greater or less than or equal to.
Yeah, so 0 is going to be basically equal to 0. Think about the graph, okay? If I was actually graphing this point of 0, and I have less than or equal to, am I going to have a closed dot or an open dot? What do you think? When do you use an open dot or open circle? Corey, what'd you just do? Yeah, so open is when it's less than or greater than. Closed, it's less than or equal to or greater than or equal to. So I would have used a closed dot. So that means I'm using equation 1. So the f of 0 is going to be -2 times 0 plus 10. And so I get 10. And we kind of already answered A, but we used equation number 1 because it's less than or equal to, so it includes 0. All right, and my last example for you is the exact same thing. The only difference is that we're only going to use, like, up here it was less than 0. So it was basically any negative number, we used equation 1, right? Well, this time, I'm only going to use a certain range. I'm only going to use from this point to this point. So if I say equation 1, f of x equals 10, flat out, the answer is just 10 if it's between -3 and 5. So if you think from a number line standpoint, from -3 to 5, any number within those, and we've got open circles because, oh no, I'm sorry, we have an open circle at -3 and a closed circle at 5. My answer is just flat out going to be 10. Okay? And the same for equation number 2. This time, I'm using any number that's going to go from 5, but I'm not including 5 because that's in the first one. That goes to 9. So any number within there, I'm going to use the -3x plus 9. Does that kind of make sense? All right, so -2. Which one is that going to fall under? 1 or 2? It's going to fall under 1 because -2 was within that range. So my answer is just 10. Okay. How about 5? I've got 5 on both of them. Which one does it include? Corey.
Equation 1 is 5.
Perfect answer. Equation 1, because 5 is included with a closed circle. So the f of 5 is 10. What about 0? Where is 0 going to fit on my number line? Yep, I'm going to be right here, so that means f of 0 is 10. And what about my last one? Number 2, because 8 comes right before 9. And so that means that I have to actually do a calculation this time. So -3 times 8 plus 9 is going to give me -24 plus 9, which gives me, what, -15? Good. Okay, flip over, back side. There are 3 sets, all right? Let's take like 10 minutes, knock this out, and then we'll work on our roller coaster. How's that sound? Deal? Awesome.